Greetings, Math 10 students. In this video we're going to take a look at finding the slope of a line if you're given 2 points. This is something that comes up in section 6.3 of the textbook, but you'll also have to do it in section 6.4 of the Hawks assignments. Both sections will make heavy use of this following process. So let's take a look. First thing, you're going to need the slope formula. The slope formula looks like this right here. They are going to give you 2 points, x and y, and it's going to be y minus y over x minus x. You'll notice in the textbook they put 2's and 1's in here. Those aren't really, strictly speaking, absolutely necessary. They're kind of little name tags on the x's and y's to let you know that you have to do the x and y from the same point first and then from the other point last. But it doesn't actually matter what order you do those in. So let's see if we can do the following problem. Find the slope of the line between these 2 points, 10, 5 and 4, 2. The very first part of this process is that you're going to label the x and y for each point. So let's go ahead and do that. It's always alphabetical order, so x first, then y. X first, then y. So 10 is an x, 5 is a y, 4 is an x, 2 is a y. Great. Step 2. I'm going to use that slope formula. Now I like to actually think about this formula more as a process than the formula written up here. I think about it as a fraction bar, and I put my 2 y values on top and my two x values on the bottom, and there's a minus sign between them. I'm color coding the minus sign green here, and I'll explain why on the next slide. So let's put our fraction bar down, and I'm going to put my 2 y values on top. So 5, and then there's a minus sign that's part of the equation, so 5 minus, oops, and I was going to color code that as green, so 5 minus, and then my 2. And then on the bottom of my equation, I'm going to put my 2 x values. So 10, and then minus, and then 4. And then my last step here is just evaluate going across and then reduce to lowest terms if necessary. So on top, 5 minus 2 is 3. On the bottom, 10 minus 4 is 6. So I've evaluated and I have to reduce that fraction to lowest terms. Well, 3/6 reduces to 1/2. Now you might be thinking, wait a second, in the book they always do the second point first. And you can do it that way, but it doesn't really matter which point you use first. And to illustrate that point, I'm going to do it with the 4, 2 as the first point next, just to show you get the same answer. If you feel comfortable with what I've done right now and don't particularly care, you can skip the next minute of this video. So let's see if we can do that again, starting with the 4 and the 2. So I'll start with my y values first, the 2 and the 5, and I will do 2 minus sign 5. And then on the bottom, I would have the 4 minus the 10. And you'll notice that 2 minus 5 now is going to give me a negative 3. Uh-oh, looks like we have a problem. I'm getting a different answer. But it balances out because 4 minus 10 on the bottom is going to give me a negative 6. And when I reduce this, a negative divided by a negative will give me a positive answer. And so I still get positive 1/2 in lowest terms. So you get the same answer either way, regardless of which point you start with, as long as you're consistent. The first 2 numbers in your slope equation on the top and bottom have to come from the same point, in other words. Let's take a look at a couple more examples just to make sure that we see all the different little tricks that can come in when negatives come into play. So let's see if we can go through the process here. I've got my 2 points and I'm going to label them x and y, x and y. And if you're watching this video at home, go ahead and click pause and see if you can work through this problem yourself. Unpause and see if we get the same answer. Alright, did you get it? Let's see if we can do this one. I'm going to put my y values on top, and I'm just going to go left to right, so 6, and then there's a minus sign that's part of the equation, and I have 21 as my second y value. And then on the bottom of my fraction bar, I'm going to start with the negative 4 for x, and then there's that minus sign that's part of my formula, and then I get my second x value of 1. Now on top, this isn't so bad. 6 minus 21, I've got different signs, so I subtract 6 from 21 and get 15, and I keep the sign of the larger number. Now this minus sign originally was part of the formula, but it belongs to the 21 now, so that's going to give me a negative 15. Downstairs, something interesting happens in the denominator here. I have a negative 4, and this minus sign that was part of the formula now belongs to the 1. So negative 4 and negative 1. In other words, I have the same sign, so I'm actually going to add those two values. If I owe you $4 and I owe you another $1, I'm going to owe you 5 altogether. Same sign, you add the values, and you keep the sign of the larger number. So now I've got my fraction negative 15 over negative 5. And in this case, when we reduce, you'll see this comes out to a whole number. 15 divided by 5 is 3, and a negative divided by a negative will give me a positive answer again. All right, let's take a look at one more, and this is the worst case scenario. Look at all these negatives. So I've got x, y. I always label these first, and it seems like a minor detail, but this will help you avoid making mistakes when putting the numbers into the formula. So I strongly encourage you to actually do that step 1 and label those points. Go ahead and again, pause the video and try this one out at home, and come back and see if we get the same answer. Alright, so this one was kind of sneaky. Let's do our y's first. And something interesting happens when we do the y's here. So I'll take a look at my two y values, 2 and negative 5. I'm going to be very careful as I put these in. So I've got my 2, and I'm going to put that minus sign in for the equation, which I've been color coding in green, and you'll see why now. And then my y value is a negative 5. So I have another minus sign and 5. I've got a double negative here, and we're going to have to deal with that. We'll see what happens. I'm going to write out the denominator first, and then we'll see what happens when you have those two negatives. You might remember from section 1.10 how to deal with that. On the bottom, we're going to start with negative 7. I'm going to put my minus sign for the equation, for the formula. And again, my x value is negative 4. So again, a double negative. So what happens with these double negatives? Two negatives in this situation will make a positive. And the way that I like to kind of show this, just so that I remember and don't make any mistakes, I see that gap between the minus signs and I fill it in with a vertical bar, and I kind of stretch a bridge across them and make it into one big plus sign. Don't try to do too much arithmetic in your head with negatives, because it can get very tricky and overwhelming, especially if you've got more than just two numbers. So I would recommend actually writing that out. Just put that little note in there so that you see, oh, that's become a positive 5 now. So this is 2 plus 5 on top, and both are now positive. So that's going to give me a 7 in the numerator. And then on the bottom, something similar is going to happen. I'm going to have that double negative situation. I put my little bar in here to make this into one big plus sign, and now my second number, 4, is positive. The first number, however, is still negative. That 7 is still a negative. If you went to school for a certain period of time, I think during the 90s they used to call this keep, change, change. That might have been in the 2000s, I'm trying to remember. And in the 90s they used to say add the opposite. There's different mnemonic devices that I've heard over time for dealing with this situation, but dealing with that double negative can be a little bit tricky, so make sure that you practice that, and definitely check out section 1.10 in the textbook and in Hawks if you're having difficulty with this. So here, the negative 7 and the now positive 4 have different signs, so I'm going to subtract them, and that's going to be a negative 3. Negative because 7 is bigger than 4. So this is my final answer. However, if I try to type something like this into Hawks, Hawks will get mad at me because Hawks does not like negative signs in the denominator. So if that ever happens, just put the negative sign out front or in the numerator, and I get negative 7/3. That negative sign, if you have one negative sign in a fraction, you can think of it as a positive divided by a negative, and a positive divided by a negative will always give you a negative answer. Same thing with a negative divided by a positive, so that's actually literally the same answer you get if you had negative 7 divided by positive 3. Either way is the same. So to summarize, finding the slope between 2 points, you're going to label your points x and y, and then you're going to put them in the equation, which has the two y values on top and the two x values on the bottom. Always make sure to put in an extra negative sign between those numbers for the equation on the top and the bottom. And then make sure that you're super careful with the negatives. Most mistakes with these problems happen with those negative signs. In the end, always make sure to reduce to lowest terms and make sure that your denominator isn't negative. If you have a negative divided by a positive or a positive divided by a negative, it'll make your final slope negative, whereas two negative signs will cancel.